All right, we are going to talk today about operations on functions. So operations, just like our childhood game of operation, but in mathematics, when we think about operations, we want to think about kind of going back to the basics. So functions, which we've been studying for quite some time, can be combined using addition, subtraction, multiplication, division, and something called composition. Composition is kind of the next level, if you will, of operations on functions. So this video is just going to go over addition, subtraction, multiplication, division. We'll have a separate video that focuses on that composition situation. So when we see the notation f plus g of x, what that really means is just take your function f of x and add to it your function g of x. Pretty straightforward. When we see f minus g of x, that just means take your function f of x and subtract your function g of x. Out of these two, make sure you pay close attention. In this one, order matters because g of x is being subtracted from f of x, so you'll most likely need to be really careful about distributing a negative sign to your function g. This right here, little dot, means multiplication. So I'm going to take f of x and I'm going to multiply with g of x. This one, f divided by g of x, means we're going to take f of x and divide by the full function g of x, making special note that your domain needs to be considered because g of x can't be equal to 0. We know if g of x was equal to 0, we'd have a divide by 0 situation that would be no good. So for our division, our order matters because g of x needs to be in the denominator, and then we need to pay close attention to that domain because we cannot have a situation where we divide by 0. For all the following examples, we have f of x is this function right here, and g of x is this function right here. We are supposed to find h of x and list the domain. Okay, well, this first one, h of x, says take f of x and subtract from that g of x. So I'm going to do just that. H of x will be equal to my function f of x minus, and since we're subtracting, we want to keep g of x in parentheses, so we make sure we distribute accordingly. Well, cleaning this up, I have h of x equals, I've got 3x squared plus 6x minus 4 minus x squared plus 8, because that negative sign distributes in. Still cleaning up, h of x will be equal to 2x squared plus 6x plus 4. So there's my final cleaned up h of x. To think about the domain, well, this domain was just a polynomial, subtracting another polynomial, and I had a result that was still a polynomial. And we know that the domain of a polynomial is going to be all real numbers, negative infinity to infinity. Knowing what I just did for h of x, I want you to try, for number 1 h of x, I want you to try number 2 h of x. So go ahead and pause your video. When you're ready, you're going to take g of x plus f of x and list the domain. So go ahead and pause your video now and try it out for yourself. Okay, so I have g of x in red and f of x in blue. Add those two things together, you end up with h of x that I have written here in purple. And then our domain, because we have, again, polynomial adding to another polynomial, we have a result that's a polynomial. Our domain is still all real numbers. Looks like I put question 3 on, did I not put question 3 in here? Oh, there it is. I just didn't scroll down far enough. Great. This one we're going to have h of x is equal to 2 times g of x. Well, g of x was x squared minus 8 minus 3 times f of x, which was 3x squared plus 6x minus 4. Go ahead and take a second, do your distribution, and combine like terms. Pause your video and unpause when you're ready to check. Pause now. All right, so I distributed 2 times x squared is 2x squared. 2 times negative 8 gets me negative 16. Negative 3 times 3 is negative 9. Negative 3 times 6 is negative 18. And negative 3 times negative 4 gives me positive 12. Combine like terms, we have another polynomial whose domain will be all real numbers. Let's make things a little more interesting. We're going to switch it up with our functions. So we have still an f of x and a g of x. This time f of x is 3x minus 4. Actually, I'm going to keep that as a blue function for some color coding. And g of x will be 2x plus 1. We're going to find h of x and its domain. So for number 4, h of x says we're supposed to take f of x, use parentheses to keep that as a group, that's a function, 3x minus 4 times 2x plus 1. Well, in order to do this, I'm going to need to do a little distribution. So some of you might do first outside, inside, last. I'm just going to go and make sure I distribute each one. So 3x times 2x is 6x squared. 3x times 1 is 3x. Negative 4 times 2x is negative 8x. And negative 4 times 1 is negative 4. So just making sure we've distributed each one of the blues to each one of the yellows. Combining like terms then, I get 6x squared minus 5x minus 4, which again has resulted in a polynomial. So my domain, oh, I'm so shocked, is negative infinity to infinity. So let's make things more interesting. H of x, huh? H of x says to take f of x and divide it by g of x. So h of x will be equal to f of x divided by g of x. And that's it. There's nothing I can clean up there, right? There's no division I can do. There's no factoring that's going to happen here. But my function, h of x, is not a polynomial. My function, h of x, is a ratio of functions. This is a rational function. And for a rational function, remember we have to say whatever is in the denominator cannot be equal to 0. Well, that means that 2x cannot be equal to negative 1, which means x cannot be equal to negative 1/2. So when we go to write the domain, our domain for this one, because we no longer have a polynomial, our domain is everything negative infinity until negative 1/2. Don't touch negative 1/2. Joined together with negative 1/2 until infinity. So it's every real number in the world except negative 1/2, because that would make us divide by 0. We've done addition, subtraction, multiplication, division. It's like, well, what is there left to do? Subtraction, addition, multiplication, and division, but this time using a graph. We got to make sure we can read these things. So I have g of x this time in blue, and I have f of x in red. This first, f minus g of 3, would say take f of 3 minus g of 3, right? Thinking about our notation from the very beginning of the video. Well, f of 3 says count to 3, read the output of f. So that's going to be 2 minus g of 3, input is 3, read the output of g, g is sitting right on the x-axis, so that's 0, which means that f minus g of 3 is just equal to 2, which is 2 minus 0. F plus g of 1 means take f of 1 plus g of 1. Well, f of 1 says go to 1 on the x-axis, read f of x, and that's going to be 0, plus g of 1, I go to 1, read the y value, 2. So this whole thing is just equal to 2. Moving on again, f times g, this should really have some parentheses around it, sorry about that. F times g of -1 would say take f of -1 times g of -1. And then this last one, f divided by g of 6 would say take f of 6 and divide by g of 6. So I want you to take a second for yourself, use the graph, see if you can figure out what the multiplication answer should be and what the division answer should be. Pause your video. Try for yourself. So I came up that f of -1 was equal to 2 and g of -1 was equal to 0. Well, 2 times 0 is 0, so that's my final answer right here. F of 6, I kind of just pretended that 6 was here. Sorry, your graph was a little cut off. Was 2. And g of 6 looks like it's about 1 unit up. So we're going to go with 3. And we're going to say 2/3. Probably should have given you a better graph. I apologize for that. Just to summarize, we can add, subtract, multiply, and divide. You want to be careful when you're subtracting that you distribute your negative sign. And you want to be careful when you're doing division that you don't inadvertently divide by 0 because you forget to think about domains.